Hey, I'm going to show you how you can use the reference materials to your advantage on the STAAR. The first page just gives you a bunch of conversions. You can use your conversions and build tables from them. For example, I take 1 gallon equals 4 quarts, or I'll take 1 liter equals 1,000. Build a table. Now skip count. 2,000, 3,000. Right? Okay, continue building tables to find your answers if you're given a ratio. In 7th grade, they are most likely going to give you a conversion, and you can build tables to find your answer. Okay, with centimeters, that line that's a little longer than all the other ones, okay, is the halfway point. So if you're needing to measure in centimeters, you always start at the 0, right? Put this right against whatever you're measuring. Okay, and put 0.5 in between each one. So 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and so on. Okay, let's go to the other side of your reference materials. We'll start off with our inches too. The longer line is always your halfway, so that's always going to be 0.5. So you're starting at 0, 0.5, 1, 1.5. 2, 2.5. Okay, that other longer line that's in between those are your quarters. Okay, so those, just think about it as money. Between 50 cents, there is 25 cents. 25 cents, 50 cents. Your next one is 75. 1 whole, or $1, 1.25, 1.50, 1.75, 2, okay, and so on. So if you are measuring something and they say to the nearest whole number, or to the nearest quarter, okay, I want to see which one it's closest to. For example, if I say to the nearest quarter, well, this one is closest to 1.5, so I'm going to say 1.5. If it were closer to 1.75, then I would say 1.75. Okay? Alright, so those are your inches. Now we got a bunch of information here, okay? These are freebies. We don't have to memorize any of these. So let's take a look at how each of these can help us. Okay. You're not familiar with slope-intercept form, okay, but we can use this because we've used equations before, and I'm just going to put the numbers in here. I see this k right here. Well, k I can put in front of this x, so k times x, and that b just represents any number, so I can just pick 2. Okay, so another example would be y equals, that k could be 3, 3x plus 2. Just in the form of an equation, okay? Remember our k value, or constant of proportionality. See the k value. You might see that word. You might say unit rate, rate of change, remember this line right there means divide. Is y divided by x. Y divided by x. Okay, we see circumference. Remember that little r? This little r is radius. Radius is a little guy, okay? It is from the center to the edge. That's radius. Diameter goes all the way across, but it has to pass through the center. That's diameter. What else do we see? Okay, this, half of base times height. To find half of something, guess what? You can also do base times height divided by 2. Okay, what else? Rectangles and parallelograms. Okay, this formula works for squares. Remember, squares have all the same sides. Works for rectangles, where I have this as a matching side, but these two are different than this, but they are the same here. 2 sets of parallel lines, or it can go like this. This is a parallelogram. These two match, and these two match. Let's look at trapezoids. Trapezoids have two bases, base 1 and base 2. Okay, so the one that you're used to seeing has a short base at the top and a longer base, and then the other two sides connect. Okay, so I'm going to be adding this side plus this side, multiplying by the height. Remember, the height always has to form by a 90-degree angle with the bottom, then dividing by 2. Okay, that's not the only type of trapezoid. I can have a trapezoid standing up where I have a long side and a short side like this. So that's a trapezoid. Those are the two bases that are parallel from each other. This would be my height. This is my height, because I can turn this sideways and now I can see the two bases, the height. Okay, then divided by 2. Alright, for the area of a circle, I've taught my students this all year long. When I see r to the second power, we think of r times r. So use pi times r times r. R times r. This is the one to use, so you don't mess up the exponent there. Capital B. Capital B, you notice this is a little b and this is a capital B. Okay, so capital B's are the area of the base. Area of the base is an entire shape. So if I'm talking about a prism, I'm going to have two bases. Two bases. Then they connect. Okay, well, capital B is the area of the base. So I would have to find the area of this base. How? By using this formula, half of base times height. Half of base times height. Okay, or the base could be a rectangle, so then I would use base times height. So then I'd use that formula. Okay, so prisms have two bases. Pyramids only have one base, so I can have a base that's a triangle and then one point where they connect. Okay, so it looks like a cone, or it just has one point at the top. This is my one point at the top. Or I can have a rectangle base. Connect all those, and there's your pyramid, okay? Remember, pyramids are always divided by 3. Always divided by 3. So you take your 3 dimensions and you divide by 3 at the end. That's the thing about this. You see capital B times H, but really you can just use length times width times height. 3 dimensions. You are multiplying 3 dimensions. You are multiplying 3 dimensions, but then dividing by 3. Alright, pi. If you forget what pi is, it's right here, 3.14, but just use 3. It's about 3. The distance formula, we don't use that in math, but there might be a question where they'll ask you, and there's your formula. Simple interest. Okay, remember P stands for the amount. That's the cash. That's what you're borrowing or what you're lending out. That is P. I stands for interest. You see it right there, interest. Okay, R times R. R is the rate, and the rate needs to be in decimal form. Okay, so times the rate times time. Time is years. So P times percent in decimal times years. It'll look like this, something like this. $5,000 I borrowed. Interest was 3%, so change it to a decimal. And I took the loan for 10 years times 10. Okay, same thing for this one. Anytime they are giving you looking for rate, always change your rate to a decimal. So if the rate is 7.5%, okay, I see the decimal, but this is a percent. That means it's out of 100. In order to make it not be out of 100, I am going to move the decimal 2 times to the left. So my actual decimal equivalency of 7.5% is 0.075. Alright, that is this for reference materials. We are going to do a brain dump now.